Imagine watching the sun's glare fade as a hidden visitor slowly emerges into view. For weeks, 3I Atlas vanished inside the sun's overwhelming brightness like a stone dropped into light.
But when it returned, it shone far brighter than any prediction dared to suggest.
I've observed the sky for decades, yet this rise in brightness still surprised me.
What kind of object grows stronger after passing behind the most intense light in our system?
3 satellites, each in the perfect vantage point, captured the first clear images.
Their instruments revealed something extraordinary, something I've never seen from a natural comet.
Atlas wasn't just bright. It was wrapped in a massive blue halo.
That halo stretched almost 300,000 kilometers, nearly the Earth-Moon distance.
Picture an entire Earth-Moon system glowing in one unified blue shell. Comets shine by reflecting sunlight, but this glow looked far too strong for reflection alone.
Something in Atlas appeared to generate its own light, as if powered from within.
To understand the mystery, we turn to spectroscopy, our tool for reading cosmic fingerprints.
And the first results were so odd that the team ran the test again and again. Atlas contained almost no water, making it drier than the Atacama Desert on Earth.
Most comets are icy time capsules, but this one was nearly bone dry.
Then came the discovery that made us all lean back in silence.
The metal inside Atlas matched nickel and iron ratios found in industrial alloys.
That is not what we expect from anything formed naturally in deep space.
Instead of being made of ancient ice and dust, Atlas felt engineered, almost intentional. So what kind of cosmic traveler carries a metallic signature like machinery? Could this be a strange fragment from a failed planet's core?
Or is it something entirely different? Something we've never classified before.
The blue halo remained the most puzzling feature, glowing hotter than expected.
Objects that close to the sun should redden, not turn vivid blue.
The color suggested temperatures beyond what sunlight alone could produce.
Something was adding energy, and it wasn't the sun.
Imagine an engine glowing beneath a metal surface, but on a planetary scale.
I'm not saying Atlas is artificial, but its behavior challenges natural explanations.
Science progresses whenever we meet something that refuses to fit the rules. And Atlas breaks rules the way lightning splits a night sky. When it emerged from behind the sun, its brightness jumped instead of fading.
Natural comets usually lose energy near perihelion, not gain it.
Atlas behaved like a system charging itself as it passed the sun.
What if it wasn't just surviving the sun's heat, but using it?
A halo that massive requires a continuous source of power. Yet no known natural process produces that scale of emission.
Even its material composition
pushed against familiar boundaries. Nickel and iron should point to planetary cores, not roaming interstellar comets. But Atlas wasn't fragmented. It was intact, deliberate, unified. Some asked whether we were looking at the remnants of a long-dead world.
Others wondered if this was evidence of processes we haven't discovered yet.
But the truth is, we simply don't know yet. The halo's sheer size forced us to rethink energy distribution in space.
If natural, Atlas would challenge how we model heat, metals, and light.
If not natural, then the universe is far more inventive than we imagined. The more we studied it, the less it resembled anything in comet catalogs.
Its dryness alone breaks the definition of a comet by a wide margin.
Comets carry ancient water, but Atlas felt like forged metal drifting through space. Even its brightness curve defied physics by rising as it neared the sun. It acted like a system responding to energy, not merely enduring it. Imagine a lantern growing brighter as you walk it into a fire.
That is the kind of paradox Atlas placed in front of us.
The halo even appeared structured, almost rhythmic in its changes.
Rhythmic light often implies controlled plasma, not random shedding.
Yet no instrument detected chaotic debris like we'd expect from a natural object. Instead, it remained stable, smooth, bright, and strangely calm.
The lack of water changed everything about how we interpret its behavior.
A dry comet emitting blue energy is like a frozen lake catching fire.
Every new measurement pulled Atlas further from the natural category.
But science doesn't fear the unknown, it pursues it.
And Atlas gives us a perfect chance to expand what we think is possible. Its metallic signature remains the hardest clue to ignore. A frozen relic from another star should look like refined alloy. So the question becomes simple. What forged this?
Nature can surprise us, but it rarely mimics engineering so precisely.
Whether natural or not, Atlas stands apart from every object we've cataloged. Its behavior near the sun remains a puzzle that models can't solve. A blue halo that large raises questions we can't yet answer. Could Atlas be using sunlight rather than enduring it? Or is it releasing stored energy built long before reaching our system? The metallic readings suggest a past shaped by intense heat and pressure.
But no known natural process matches all of Atlas's traits at once. Whatever Atlas is, it challenges our assumptions about interstellar visitors.
Its return from behind the sun
marks the beginning of deeper investigation.
The next phase is understanding how it stores and emits energy.
That halo may hold the key to a process we have never documented before.
Science thrives on anomalies, and Atlas is a gift wrapped in mystery.
We may not know its origin, but we know it's unlike anything we've studied.
Atlas invites us to question what lies between stars and what journeys in silence.
Imagine standing under a dark sky as a strange visitor changes direction unexpectedly.
For decades, I believed comet tails always point away from stars.
But 3I/Atlas defied that rule, ejecting material toward the sun itself.
Picture an elderly African-American man's short, gray hair blowing into a fan instead of away from it.
That inward jet suggests a force acting like a deliberate thrust.
In space, any small push can change trajectory enormously over time.
Imagine a spacecraft performing tiny course corrections with measured bursts.
Atlas's plume seemed like such a correction, not random shedding.
We do not claim intention, only motion that resembles control.
That observation forces a question. What drives those inward emissions?
Next, our thermal data revealed another unsettling fact.
Atlas appeared to emit more energy than it received from sunlight.
Think of a rock that glows brighter than the fire shining on it.
Such a discrepancy violates our usual energy balance expectations. So where could the extra energy originate?
It could be internal heat, chemical release, or an unknown mechanism.
We must remain cautious.
Anomalies don't equal answers.
Out of here.
Still, the data demands new hypotheses and rigorous testing.
Adding to the puzzle was Atlas's path into our system. It approached nearly aligned with the plane where planets orbit. Statistically, that alignment is highly unlikely for a random interstellar rock. Imagine thousands of random arrivals. Very few match the planetary plane.
That coincidence forces us to pause and reevaluate assumptions.
Could dynamic interactions or gravitational assists explain the alignment?
Or might selection effects make such alignments more observable?
Either way, the orbit adds a statistical wrinkle to the mystery.
Now combine the inward jet, excess emission, and orbital alignment.
Together, these features push Atlas away from typical comet behavior.
We must ask clear, testable questions, not sensational claims.
First, can the inward jets be reproduced by known physics?
Second, what internal or external energy source could power excess emission?
Is the orbital alignment a fluke or a clue?
Good science demands data, replication, and humility. Observatories worlded, retasked to monitor Atlas closely.
Radio dishes listened for unexpected signals or maneuvers.
Infrared surveys searched for heat signatures matching the anomaly.
Spectroscopy probed chemical composition and metallic clues.
The composition surprised us. Metallic signatures dominated, not ice.
That dryness and metal content deepened the puzzle further.
A dry, metallic interstellar object is not what classic comet models predict.
We explored whether surface processes could mimic thrust-like jets.
Sublimation of volatile pockets can cause jets, but usually away from the star.
Atlas's inward-directed activity resists those simple explanations.
Could magnetic interactions with the solar wind play a role?
Plasma physics can produce complex flows around conductive bodies. Still, matching the observed energy budget remains difficult. That's why coordinated, multi-wavelength observations matter.
Each wavelength reveals a different facet of the phenomenon.
Repetition of measurements reduces error and sharpens the mystery.
Peer review and independent checks guard against mistake.
The goal is clarity, not conjecture.
Agreed. The evidence is compelling.
What might an internal energy source look like conceptually?
Radioactive decay, exothermic reactions, or stored chemical energy are candidates.
Each hypothesis carries testable predictions for emission patterns. Simulation markers predict where jets should appear if hypothesis true.
If internal energy drives emissions, we expect consistent spectral markers.
External interactions drive it. Emissions vary with solar environment.
Atlas challenges us to expand our models, not abandon them.
Science advances by confronting anomalies like this one.
The more anomalies we observe, the more robust our theories become. Atlas's inward jets, excess emission, and orbital tilt form a coherent puzzle.
We must follow the evidence wherever it leads. Curiosity intact.
That means continuing to observe, simulate, and question.
It also means preparing to update long-held assumptions.
If Atlas represents a new class of interstellar object, our catalogs change.
If it reflects unknown physics, we gain avenues for discovery. Either way, Atlas reminds us that space still surprises.
For now, we watch, measure, and test relentlessly.
And we keep asking, with measured curiosity, not haste.
What would it mean if internal mechanisms powered these jets?
It could reshape our understanding of interstellar materials and dynamics.
Or it could be an exotic, natural outcome we simply never observed.
The key is rigorous observation and patient analysis.
Atlas is an East Asian female teacher disguised as a mystery.
And every good lesson begins with a question we're brave enough to ask.
We will keep watching 3i/Atlas until answers form from evidence.
For now, the universe has handed us a dilemma rich with promise.
Imagine watching a distant visitor show light patterns no database can explain.
Every natural object reflects light in predictable ways, but Atlas refuses those rules.
Its light signature looks like a fingerprint from no known material.
Think of opening a dictionary and finding a word from no language on Earth.
Atlas reflects light as if its surface is made of something unclassified.
No comet, asteroid, or interstellar rock shows polarization like this.
Scientists rechecked the data, expecting an error, but the signal held.
So we must ask, what kind of surface produces such unusual light?
Is it rough, smooth, layered, or engineered in ways we can't yet imagine?
Then came the second anomaly, its strange accelerations near perihelion.
As it approached the Sun, Atlas sped up in ways gravity alone cannot explain. After passing the Sun, it accelerated again, as if pushed a second time.
Imagine walking downhill, then suddenly moving faster, without taking extra steps.
These small kicks resemble something pushing from within, or from an unseen force.
We saw something similar with Oumuamua years ago. Back then, we had no answer, and today the question returns stronger. If Atlas contains almost no ice, these accelerations cannot come from evaporation.
And that dryness is its third major anomaly, only 4% water.
A normal comet holds 80 to 90% water ice.
But Atlas is more desert than ice, more metal than frost. Without ice, it cannot produce the jets needed for natural acceleration.
So what created the impulses that altered its speed?
Could it be internal heat, chemical pockets, or something stranger?
Could solar plasma interacting with its surface create unusual thrust? Or are we witnessing a new category of interstellar physics unfolding?
Each possibility pushes us beyond comet science and into exploration. The polarization alone suggests a surface unlike any natural sample we've studied. The strange acceleration suggests forces we haven't modeled yet.
And the dryness shatters our expectations for interstellar travelers.
Put together, these clues form a puzzle, reaching past our old assumptions.
Science thrives when faced with mysteries that resist quick answers.
But mysteries demand disciplined curiosity, not conclusions.
Atlas gives us exactly that, a chance to rethink how objects travel between stars.
Its polarization acts like a coded message written in reflected light.
But it's its message. It's written by nature or something else far beyond us.
Could microscopic metallic grains cause this unusual reflection?
Perhaps its surface is layered in ways light doesn't normally encounter.
The acceleration remains harder to place in known physics.
Gravity alone cannot account for its motion before and after perihelion.
A natural jet would require ice, pressure, and heat, but Atlas lacks all three.
This forces us to imagine unfamiliar mechanisms at play.
What if Atlas contains internal structures that expand when heated?
What if solar radiation triggers chemical reactions beneath its surface?
Or what if it carries materials that behave differently near strong magnetic fields?
Dryness limits what explanations make sense.
With so little water, it behaves nothing like a comet. In fact, Atlas behaves more like a metallic shard than an icy relic.
So perhaps we must widen our taxonomy of interstellar objects.
The universe rarely fits neatly into the boxes we design.
Atlas reminds us to question the boundaries between comets and unknowns.
Polarization is easy to overlook, but here it's the loudest clue. It speaks of a surface shaped by forces we haven't cataloged.
The accelerations whisper of inner processes we cannot yet see.
And the dryness strips away familiar explanations entirely.
So what does Atlas want to teach us?
Maybe that interstellar space holds materials our system never formed. Maybe structures can form in other systems with strange, layered surfaces.
Or maybe forces near young stars imprint exotic traits on passing objects.
The acceleration might come from processes we haven't recognized yet.
We cannot assume our solar system is a universal template.
Atlas could be ancient, reshaped by environments unlike anything here.
Or it could be young, still carrying traces of a violent birth.
Its light tells us that its story is unlike anything local.
And its motion suggests a dance we have never seen before. We must approach this with humility. The cosmos rewards careful listeners. Every anomaly is a doorway, not a conclusion.
Atlas offers 3 such doorways toward deeper understanding.
Polarization invites us to rethink how light interacts with unknown surfaces. The acceleration challenges our assumptions about motion in space.
And the dryness challenges the very definition of a comet.
Together, they form a mystery worthy of patient investigation.
The goal is not to sensationalize, but to understand.
Because understanding is how we grow from confusion into insight.
Atlas reminds us that space still holds surprises in plain sight.
And not every surprise fits our familiar categories.
But that's the beauty of exploration. We learn by meeting the unexpected.
So we keep watching Atlas with open minds and steady measurements.
Each night brings more data, more questions, and more hope for clarity.
Whether natural or unusual, Atlas deepens our understanding of interstellar visitors.
And in that pursuit, every anomaly becomes a guide toward the truth. Imagine looking toward Sagittarius and seeing two mysteries share the same sky.
In 1977, we heard a powerful radio signal from that narrow region.
Decades later, an African-American female atlas enters from nearly the same coordinates.
Coincidence is possible, but the universe rarely repeats perfectly. Why would two unrelated events emerge from the same region? Some patterns are noise, others demand careful attention.
And Atlas gives us another pattern in its changing halo.
Its brightness rises and falls with a steady, repeating rhythm. Natural dust clouds don't pulse that neatly or predictably.
This looks more like an organized plasma system.
Plasma becomes steady only when something regulates it.
So what regulates Atlas's halo out there in open space?
Could internal heat cycles drive that repeating pattern?
Or does sunlight trigger oscillations we don't yet understand? Whatever the cause, its steady rhythm is strikingly artificial in behavior.
Then comes the strangest part of all. Its impossible blue color.
Atlas glows bluer than the sun, hotter than sunlight allows.
No passive object at that distance should outshine the sun in temperature.
Blue this intense usually signals extreme heat or internal power.
Imagine heating metal until it glows brighter than a star's surface. But Atlas receives nowhere near enough sunlight to reach that point.
So the energy must come from inside, not from the sun.
That realization forces a bold question. What powers the glow?
We do not jump to conclusions, but the physics is unavoidable.
Internal energy means internal processes, something generating heat. Could it be compressed plasma leaking energy outward?
Or a material phase change releasing stored heat?
Whatever it is, Atlas is not a passive reflector of sunlight.
All three clues now intertwine: origin, rhythm, and color.
The WOW signal link hints at a region worth watching.
The rhythmic halo suggests intentional order over chaos.
The blue glow forces us to consider internal power.
Science advances when patterns challenge our assumptions.
And Atlas challenges them all at once.
Imagine standing on Mars, watching Atlas pulse like a cosmic beacon.
Its light would flicker through the thin atmosphere like coded signals.
But signals from nature can look intentional when unfamiliar.
That's why careful interpretation is essential.
We must separate mystery from meaning, anomaly from assumption.
The link to 1977 reminds us that chance sometimes shapes discovery.
Yet repeated coincidences nudge us to look deeper.
Perhaps that region of Sagittarius holds unusual activity.
Or perhaps we're merely sensitive to signals from that direction.
The rhythmic halo cannot be dismissed as random noise.
Natural dust rarely forms such stable patterns. Plasma stability hints at a boundary or structure maintaining order.
But we cannot yet see beneath Atlas's brilliant outer layer. The blue emission is the loudest clue of all.
Blue this strong demands energy we cannot explain externally.
If Atlas produces energy internally, we must rethink its category. It may be a type of object never before documented.
Or a natural artifact shaped by extreme conditions elsewhere.
We cannot assume it resembles anything from our solar system.
Its rhythm alone sets it apart from familiar comets or asteroids.
And the origin alignment links two distant mysteries across decades.
Nothing confirms a connection, yet the parallel invites curiosity.
Curiosity fuels science as much as data does.
And Atlas rewards curiosity with layered, elegant anomalies. Could internal heating create these oscillations?
Could Atlas possess magnetic structures that regulate plasma?
Or could the rhythm emerge from interactions with solar particles? And why does the color remain consistently blue, not shifting?
Stability often signals control, not randomness.
But control does not automatically mean intention.
It simply means processes are happening inside Atlas.
Processes powerful enough to outshine the sun in blue wavelengths.
That alone makes Atlas one of the most unusual visitors recorded.
It reminds us the universe is still full of surprises.
Surprises that ask us to observe carefully, not jump to answers.
And Atlas asks the biggest question through its radiant blue glow. How does something so distant shine with such controlled precision? And why now, from the same region, tied to a decades-old mystery?
We do not yet know, but we keep searching with open eyes.
Atlas invites us to look deeper into patterns we once ignored. Each pulse of blue challenges our understanding of interstellar objects. Each clue encourages us to reevaluate what natural means.
And each coincidence whispers that space still holds secrets. Atlas turns, glowing softly, as if waiting for the next question we'll ask.
Imagine tracking an interstellar object that vanishes at the moment you need it most.
Atlas passed near Mars, Venus, and Jupiter with perfect visibility.
But during its most revealing moment, it hid behind the sun. It chose the one angle where Earth's telescopes were blind.
I've learned that coincidences this sharp deserve attention.
I appear when the data is least useful and disappear when it matters most. Sometimes space feels as if it's playing timing tricks on us. But Atlas timing goes beyond ordinary orbital coincidence.
Was it merely chance, or an outcome of complex celestial mechanics?
The alignment feels almost too neat for random motion.
Yet we must avoid assuming intention where physics may suffice.
Still, Atlas vanished at the exact moment we needed answers.
Then comes the second puzzle. Atlas is big, but moves shockingly fast.
In astrophysics, bigger objects usually travel slower.
But Atlas breaks that rule with astonishing ease.
It moves faster than smaller interstellar visitors like Oumuamua.
Think of a heavy truck outrunning sports cars on a straight road.
That kind of speed requires immense energy or unusual origins.
No known model predicts such rapid motion for something so massive.
So what gave Atlas its incredible velocity?
Was it ejected violently from its home system?
Or shaped by an environment with extreme gravitational forces?
High speeds often leave scars, but Atlas looks strangely intact.
Perhaps it traveled through regions that gave it repeated boosts.
Whatever shaped its speed left no trace we can recognize.
Question deepens when paired with its perfect timing.
A fast, massive object should be easier to observe, not harder.
Yet Atlas picked the one moment guaranteed to obscure its behavior.
Trying to study a rare eagle that only flies behind the sun.
That sort of timing makes any scientist pause.
We cannot claim intention, but we cannot ignore precision either.
Atlas behaves like an outlier in every sense.
Its speed alone sets it apart from known interstellar objects.
And its temporary disappearance complicates everything.
Timing and velocity, two traits rarely linked so closely. Combined, they create a narrative that defies simple physics.
If Atlas was slow, we'd have studied it easily.
If it never hid, we'd understand more of its structure.
But fast objects don't usually cross our blind spots so precisely.
So we're left with a puzzle composed of timing and momentum.
Momentum this high usually demands catastrophic origins. Yet Atlas shows no signs of fragmentation or impact history. Could gravitational forces have accelerated it repeatedly?
Or is it carrying internal mass distributions that affect motion?
These ideas aren't answers, just pathways for investigation.
Science embraces uncertainty when the evidence demands it.
Atlas challenges our understanding of mass and speed relationships.
It reminds us that interstellar space can produce extremes.
But extremes rarely coincide with such perfect timing.
That timing remains the quiet oddity at the heart of this story.
I disappear when its perihelion behavior matters most.
Why reappear only after crucial data has passed?
These are questions we must consider with patience.
Neither coincidence nor intention should be assumed too quickly.
But both possibilities must remain on the table for now.
Atlas forces us to accept incomplete information.
It pushes us to refine our models of interstellar dynamics.
And it highlights where our observational blind spots still exist.
Hidden motion often reveals more than visible motion.
Atlas's behavior encourages us to track objects across all vantage points.
Speed challenges what we assume about mass distribution.
And its timing teaches us that orbits can trick even seasoned observers.
But trick or not, every observation helps refine the mystery.
We learn most when nature refuses to follow the script.
Atlas is nature, unscripted, raw, unpredictable, extraordinary.
Its speed tells a story of violent origins or unknown mechanics. Its disappearance hints at timing shaped by orbital geometry. Both ideas remain open until more data arrives.
That's the beauty of astrophysics. We live inside the questions.
And Atlas hands us questions wrapped in velocity and timing.
Nothing suggests a final answer yet, only deeper inquiry.
We may find a natural explanation that reshapes our models.
Or we may discover a type of interstellar object never seen before. Either way, Atlas widens our understanding of what's possible. Its speed teaches humility. Its timing teaches caution. And together, they remind us the universe still has surprises.
Surprises found only when we pay close attention.
So we continue to watch Atlas with every tool we have. Ground and space telescopes track it in synchronized arcs.
And we let its strange behavior guide our next questions.
For in the end, mystery is often the universe's greatest teacher.